putting together a linked list. And what that is essentially is we have data that are put into nodes, and the nodes have pointers that point to, or sorry, just one pointer usually, unless it's a double linked list, and that pointer points to another node. It's like a chain. So we're going to start off by what our node class is going to have. It's going to hold the value, and as well as have a node pointer to the next node. And our default constructor, we'll just start off by setting value to -1. Ideally, we won't be using this. It really just depends on how you implement your node class in your linked list. We'll probably be using this one more. And we'll set the value of this node to the value we just received. And next is still going to be null. Alrighty, so now we can go on to implementing this in the linked list. So our linked list is going to hold a pointer to the first node, the last node, and it's going to keep track of how many nodes are in our list. And with a linked list, you should be able to add at the beginning or the end, remove in the beginning or the end, as well as insert at a specific position or remove at a specific position. We'll start off by inserting in the beginning. And of course, we're going to receive a value to put in the beginning of our linked list. And we'll just say temporary. But this temp node is going to hold the value in our linked list. The pointer in this temporary value is going to point to the first node in our linked list. And then the new first node in our linked list is going to be this temporary node. And if the last node is null, which means it hasn't been initialized, it's going to be pointing to this temporary node now. And of course, we have to increase the count. And then, so we insert in the beginning, now we're going to insert at the end. And we're going to receive a value. We're going to go and create our temporary node again. And let's check if the last node is null. If it is null, it's going to point to this now. If it's null, then it's safe to assume that the first node is null as well. If the last node is not null, we're going to set the current last node to point to this new temporary node. It's like adding a link at the end of a chain. So the previously last node is now pointing to this, and the new last node is going to be our temporary node. This ensures that there's still a link between the two. And we have to increase the count. Alright, so we inserted in the beginning, we inserted at the end. And now, let's insert at a specific position. So we're going to assume they give us a position and a value to initialize with. So first off, we have to check if the position is valid. If the position is less than 0, or the position is greater than how many values we have in our linked list, we're going to throw a new exception. And we'll just let the user know that the position is invalid. And so if it is invalid, then that exception is going to take us out of this method. If it is valid and the position is 0, we can use our method that we already have. If it's not 0, but it is equal to the count we have, which basically means they want to insert at the end of our list, we're just going to call insert last. And if it's not the beginning or the end, we're going to go through the list until we get to that specific position, and we're going to do that by having a runner node to go through the list until it gets to that position. Our node temp is going to hold the value. And then we're going to create a node runner to go through the list. Our runner is going to be equal to the first node, because that's what's going to begin, and every node holds a pointer to the next node. We're going to create a for loop to go through the list. While I is less than the position minus 1. Runner is equal to runner.next. This is basically just telling the runner whatever node I am at, once this loop is done, I want to be the next node in this list. So once it gets there, do we want the pointer in that temporary node to point to the same node that's next for the runner. We're assuming that runner is in the correct position, and the runner is pointing to the next node. We want our node, the temporary node, to point to the next node of that runner. The runner is basically just looking for the right spot to be. Then we're going to increase our count. So now that we have that, let's go ahead and start removing. We're going to remove from the beginning first. If the first node is null, which means our list either has something wrong with it or it's empty, we're going to throw a new illegal state exception. The list is empty. And we're going to do the same thing. We're going to create a runner. We're going to create a temporary because it's going to hold the value that the first node has to return. If the first node is equal to null, last node is equal to null. We're telling it, alright, this list is now empty. We're going to decrease the count. We're going to return temp.value. So we remove from the beginning. Now let's go ahead and remove from the end. So it's going to be similar to how we did it last time. If last node is null, throw new legal state exception, and the list is empty. Since we are removing at the end, now we're going to need a runner. And what that runner is going to essentially do is it's going to go to the it's going to go to the very end, and it's going to grab that value. It's going to start at the first node, and we're going to go to the very end of the list. So with count -2, we're basically, because our list I starts at 0, so essentially our list is going to start, our runner is going to start at index 0 essentially. And we want to go to the one right before that. And we can't forget to grab the value. So this node right here, next dot value, that node holds it, but we're not going to go there. We just want to take a peek at what he has, what that node has. So now we're going to basically get rid of that node. We don't have anything pointing to it, so the garbage collector is going to come and get it. So the new last node is where the runner is. And we're going to decrease the count and return the value we got. So now we're going to remove at a specific position. We want to find what that value is at a specific position. And we're going to check again if the position is even valid. So if it's less than 0 or more than what we have, then throw the exception. If the position is 0, we don't want to insert, we're removing. So we do remove first. And we don't have a value anymore. We don't need one. And then this one basically means the end. So let's see. Now we gotta assume those, and none of that is true. And we're gonna go ahead and create a runner to get to that position. And this runner is gonna point to the first node. We're gonna basically do the same thing as before, except this time we're not gonna sever that link that the nodes have. We just want to see what that value is in the specific position. We're going to grab that value. We're going to set it equal to runner.next.next. Going back to what I said previously, I thought we were on a different method, so we actually are removing position. So we do want to sever the specific link that this position has. So this is peeking into what that value is at that position, and then this is basically saying this node that I'm currently at, the pointer to the next one, I want it to point to not the next node, but the one after that. And that's why we start at position -2, or go up to that position. We're going to subtract 1 from count, and we're going to return that value. Can't forget to return, because these return integers, and we can have if we wanted to see what a specific position has without removing whatever value is there, without severing the link, we'd basically be doing the same thing here, except we can return the first node, return the last node, and this would be a little bit different as far as it wouldn't be necessary to change the pointers.